Hi, in this video, we're going to take a look at multi-area OSPF router types and areas. Okay, so OSPF router types. We have internal routers. These are routers with all their interfaces in the same OSPF area. We have backbone routers. These are routers that have at least one interface connected to the backbone area, which is area 0. We have ASBR, Autonomous System Boundary Router. These are routers that have at least one interface connected to an external network. So it's another routing domain. We used to call these external autonomous systems, but just some other routing domain outside of this OSPF routing domain. And we have the ABR, Area Border Routers. These are routers with interfaces connected to multiple areas. And by the way, one of those areas need to be area 0. Okay, let's take a look at this topology here, which I'm going to be using throughout a lot of my videos. Again, imagine a routing domain with dozens, even hundreds of routers. Okay, let's take a look at some of the different, first of all, look at the different areas. We have an area 0. We have an area 1, and we have an area 51. Okay, what are some of our different routers? Where's our ASBR? There it is, our Autonomous System Boundary Router. So that connects to our ISP. We may be running a different routing protocol. We could be running BGP with them, EIGRP, just doing static routes. The thing is that the ASBR is that link to the ISP is not part of our routing, our OSPF routing domain. And by the way, we'll talk more about what makes an ASBR, an ASBM, and ASBR router, more specifically in later videos. Okay, we have two ABRs, Area Border Routers. And as you can see, these are routers that have interfaces connected to area 0 and another area. And by the way, you never want to have this. You don't want to have an ABR here that's connected to both area 1 and area 51. Okay, you don't want to do this because this can create routing loops. All right, let's get back to this. So our internal routers, that's what we're missing here. Where are those internal routers? Let's see. We have a couple over here in area 1. Don't see any in area 0. And we have a couple there in area 51. Okay, again, an internal router is a router with all of its interfaces in the same area. Okay, internal routers. Let's talk a little bit about them. Okay, again, interfaces, all the interfaces in the same area. Okay, so there we have one there, one there, one there, and one there. Okay, so one of the things about internal routers, within an area, they're going to have identical link state databases along with the area border routers in that area. We're going to see here in a moment that the area border router will actually have two link state databases. One, let's take a look here. Let's take a look here for R1. Here we have an area border router. Okay, it's going to have an identical link state database for its area 1, the same as this router and this router. Okay. But it's also going to have a separate link state database that it shares with area 0 routers, these three. This ABR is going to have a link state database for area 0 and also a separate link state database that will be identical with these internal routers in area 51. Okay. A lot more we'll be talking a lot more about this later videos, or at least things that will make it more clear for you. Okay, backbone routers. Where's our backbone routers? We got 1, 2, 3. These are routers that have at least one interface in area 0. Area border routers. These are the routers that connect our area 0 to another area. So we have router R1 there and router R3. Okay, so area border routers, as I mentioned previously, maintain separate link state databases for each area they're connected to. Okay, they are exit points for that area. Okay, they distribute the routing information from one area into the backbone, and then backbone routers then redistribute or forward that information to other area border routers that then forward it into their own area. This will make a lot more sense when we talk about multi-area OSPF and link state advertisements in an upcoming video here. Okay, but that's just a little overview for now. So unless using virtual links, and that'll be another video, one of the connected areas must be area 0. So I had mentioned this previously. You don't want to do this. You don't want to have an ABR here that's connected here and connected here. Don't do this. This will create a potential routing loops. Okay. And on the ABRs, you can configure them for manual summarization. It's also a point where we'll talk about, actually in a moment here, I'll introduce stub and totally stubby areas as well. Okay, but first let's finish up the types of routers with the ASBR. Where's our ASBR? Oh, there it is, right there, router R2. This is a router that has at least one interface in our OSPF routing domain, and another one connected to an external network. And again, we're going to talk more about what that actually means and how a router becomes an ASBR in a later video. This should be in area 0. Doesn't have to be, but it should be. It's a place where we redistribute network information from other sources external to this routing domain, in this case from our ISP router, into this OSPF routing domain. So what we're doing is we can redistribute routing information from the ISP, from however we learned it from the ISP, into the OSPF routing domain. It's also a place where usually we propagate a default route. So we perhaps have a static default route. I'll just put default. Oops, trying to spell default with my, there we go. So we have maybe a static default route here. And this is where we'll propagate that information throughout the rest of the OSPF routing domain, propagate the default route. Now, I had mentioned briefly about this should be in area 0. It doesn't necessarily have to be, but best practice is that your ASBR is going to be in area 0. That's because if you want the ability to have stub and totally stubby areas, which we'll talk about here in a moment, then the ASBR needs to be in area 0. Okay. So let's talk about some of these areas. We have the backbone area, area 0. Okay, this is usually just for the fast and efficient movement of IP packets, really used to interconnect other areas where we have all of our services, all of our users, and that sort of thing. Not that they can't be in area 0, but a lot of times area 0 is just for moving packets between the areas and between our external, in this case ISP, our external routing domain or external networks, and our internal OSPF routing domain. Okay, so generally users aren't found in the backbone area, but it can be. And again, we tend to put users in what we call regular or normal areas, not the backbone, like area 1 here and area 51, because that also allows us to do things, again, those stub type areas that I've mentioned a couple of times now. Okay. I mentioned the ASBR is usually in area 0 to allow for those stub and totally stubby areas. It's really thought of as the kind of the core of your OSPF routing domain. Okay, these other areas, in this case, area 1, area 51, this is usually where our users are. We usually set this up along functional or geographical locations. Again, can be configured as stub type areas. By default, all traffic from other areas must cross the ABR. So we're going to use the area border routers, in this case, right? Router R1 and R3 is what's going to be used to interconnect area 1 to area 0 to area 51. So traffic is going to move from area 1 here through the ABR into area 0, and then if it's going to area 51, through that ABR to get to area 51 devices. Okay. This will become all more clear the more we go into this, okay? All right. So one of the key things that I've mentioned previously is that any topology changes isolate the SPF calculations to a single area. And we're going to see this in more detail in a later video when I talk about the different LSAs, and you'll see why this happens and how it happens. Okay, so if we had a change in area 51, then only those routers with an interface in area 51, which of course are these internal routers, and the ABR, because it has a link state database, which is part of area 51. So only these routers would have to rerun their SPF algorithms. Okay, we'll learn that these other routers will learn about the change, but don't have to rerun the SPF algorithm. We'll see why that happens in a later video when we talk about those LSAs. Okay, all right. So I mentioned stub and totally stubby areas. So let me actually talk a little bit about this. This is where we can further reduce the size of the link state database and the size of the routing tables. Okay. So, and I'll address this again, of course, when I talk about those OSPF LSAs, right? Okay, so we'll see more, we'll address these a little bit more in a later video, but let me at least give you an introduction here. So what is a stub area? A stub area receives a default route. So first of all, the ABR, the area border router, injects a default route into the area. It says, hey, I'm your way out of the area. The routers in a stub area will see the default route, okay? And they will also see routes from other areas. So any networks routes in area 0 and area 1. What they won't see is any external networks, okay? So they won't see anything out here and beyond, okay? Why? They don't need it because they have a default route, okay? So their routing tables, their link state databases, their routing table will only see networks, first of all, networks in their area, of course, networks in area 0 and area 1, and that default route. So if they need to get to something out here someplace, they've got a default route. They're going to forward it towards the area border router. Okay, so I mentioned that there's also totally stubby. You might be actually thinking, hey, wait a minute. If I've got a default route, why do I need to know about networks in areas 1 and area 0? Exactly. So what a totally stubby area says is this. First of all, I'm going to get a default route, which is injected by the ABR, okay? So the only thing that routers internal to a totally stubby area are going to know about is they will know about networks in their own area, okay? And they'll know about a default route, and that's it. That's all they need to know, because anything else, anything out here and beyond, And anything in area 0 or area 51, they've got a default route. They're going to forward those packets to the ABR. Now, I'm going to mention that there's also something called a NSSA, not so stubby area. I won't get into that here, but I do want to mention for totally stubby and stub areas, the ASBR must be in area 0. Okay, so that's really the best practice. It makes your design options, well, gives you more flexibility with your design options and makes things a lot easier. All right, so a lot more coming when we talk about those OSPF LSAs. Okay, so a few implementation guidelines. First of all, how many routers per area? It varies based on what is the function of that area, and also network stability. You might have a site with only one router, but you might have this kind of flaky satellite link or microwave link, and you might actually put that one router and its network, its local area network, in a separate area. That way, if that link is flaky, it's not causing any other routers to rerun their SPF algorithm, calculations other than that one router. Okay, so it's a way to kind of add some network stability. So there's a case of a one router area. Okay. You can also have multiple ABRs for an area. Okay. I'm not going to go into that in this video, but maybe in later videos when I do, especially my CCNP videos, we talk about how to use the implications of multiple area border routers in an area. You can also have multiple ASBRs. And you can have an ASBR in area 0 and another ASBR in another area. Now, these are all, you have certain design considerations that you have to think about and know what the implications of all this is, and make sure that's what is best for whatever your traffic flow in your domain and what you want. All right. So I mentioned that the ASBR, can be in an area other than area 0. All right. But again, if that's the case, then it can't be, you can't do a stub or totally stubby area. Okay. But you can do that not so stubby area. Oh my God, so much. It's not bad though. It's not bad. Okay, so that's OSPF router types and areas. Make a little bit more sense to you when we look at OSPF LSAs.